Hello, epidemiology students. We're going to cover material found in Chapter 12. By far, this is my favorite chapter of the entire semester. I mean, it's not like you can't tell already from all the discussions and lectures we've had throughout the semester. But we are going to cover epidemiology of infectious diseases. Now, we've covered infectious diseases several times throughout the semester, but here we have a chance to actually talk about some unique characteristics that you need to consider when you're conducting epidemiological research or understanding studies that are published. But we're going to talk about some really interesting diseases at the same time, and that's one of the reasons why I particularly like this chapter. We have pictures that you can see on this slide where we have necrotizing fasciitis, which you guys have heard before, with group A strep. This is the type of bacteria, the flesh-eating bacteria that you've heard of before. We've also, there's a slide here demonstrating leprosy or Hansen's disease, or the infamous armadillo that we've talked about at the beginning of the semester. We're going to talk about characteristics that you can find within the environment, how different hosts or different animals can transmit disease through zoonotic transmission, as well as we're going to talk about sources of infectious disease and communicable diseases, be it with clean water. And then we'll have an opportunity to talk about some emerging diseases like Nipah and Hendra, as well as diseases that are more stable that we don't have here all that much here in Utah, like Lyme disease or tick-borne relapsing fever or Rocky Mountain spotted fever. But infectious diseases are important. They are a significant cause of morbidity and mortality throughout the world. We sometimes become a little lackadaisical when we talk about some of the infectious diseases, such as influenza or flu. But when you take a look at flu, for example, there's between 3,000 to 49,000 individuals die as a result of being infected with influenza and complications that come with that. As I've already described in the course before, my grandmother passed away a couple of years ago as a result of being infected with influenza and then having complications that arose through pneumonia and that. She was elderly, and that's where these deaths are often associated with the elderly population and the very young. But epidemiology is used whenever we talk about infectious diseases. You can see, for example, the CDC through the FluNet group, they will provide reports as to where we are when we talk about the progress or the status of influenza on a yearly basis. And you can see on the left side of the screen is showing influenza, what it was at around our time a year ago and how it compares to today. And you can see that, the colors are different, but when you get really close, you'll see that the subtypes are similar. But what you'll see also is that we have more cases this year. There's been an uptick. And you can see that even more so when you look at this particular slide, looking at the peaks and valleys, or when it becomes endemic versus epidemic, when it crosses over that threshold to where it's considered an epidemic. And you can see, for example, in 2015-16, you can see the number of cases, but you can see here that we are more steady this year as to the number of cases. Now, it doesn't peak like we saw back in 2014-15, and that has a lot to do with the vaccine not being all that effectively matched to what was actually being transmitted within the population. But it's almost on any given day, you can watch the news and you can see and hear about different types of infectious diseases and how epidemiologists will contribute to trying to help mitigate or control these. For example, with drug-resistant bacteria that are constantly being spread throughout the United States, or Shigella being a bacterial diarrheal disease, and we'll cover that one in just a couple of minutes. We've spoken quite a bit about Zika virus, and we'll spend a couple of minutes at the end of this discussion talking a little bit more about Zika so that you will be the expert and be able to teach your family about importance of Zika, but also the non-importance of it, at least for now, here in Cache County. And then we still have plague, and cases of plague that are occurring on a yearly basis, as well as many of you are aware of just a couple of years ago with the Ebola outbreak that happened in Africa and the few cases that we had here in the United States. But as we take a look at infectious diseases more on a local basis, whooping cough is one of those that as epidemiologists at the state as well as at a local health department standpoint, it's a real concern. It's a bacterial disease. There's an excellent, amazing method of control for that, and that's a vaccine. And it's given through the DTaP, the diphtheria, tetanus, and pertussis vaccine. It's given out, or it's recommended to be given to children at 2, 4, 6, and 15 to 18 months, and then at 4 to 6 years, as well as a booster every 10 years. And that's where the real issue comes in, is that the vaccine is being distributed quite well when at a newborn as well as a childhood age, but as adults we aren't receiving that booster shot. And I could probably ask you or have a number of you raise your hands, and many of you are over the age of as to when you ought to have had your booster, and many of you will not raise your hand, I suspect, because it just doesn't happen. Physicians are not recommending it. It's not that they're not intentionally recommending it, it's just not given out because of just the ages that people will go in to receive for other treatments. But Utah has 5 times the national average of whooping cough, and it's a real concern from the standpoint of when little children are infected and the complications that can come with that infectious disease. As I said, infectious diseases are a significant cause of morbidity and mortality worldwide. Aspects as to why it becomes even more important has to do with the ability that we can travel almost anywhere in the entire world within 24 hours now. And that's commonplace, where an individual can be in one part of the world and then within 24 hours can be on the opposite side of the world. The example that I have given already in this class is a couple of years ago I had the opportunity to travel to Istanbul, to Turkey. And I left on Saturday morning in Istanbul, and I arrived in Logan by Saturday evening. And so, I'm following, of course, the sun and the date, and the time changes with that. But within 24 hours, I was home and with my family. And had I contracted an infectious disease that was respirable, I could have had the ability then to transmit it to family members, and it could have gone from there. Another aspect with infectious diseases that's of importance is that some are associated with cancer, and we've talked about that with HPV, with cervical cancer. But we know that HIV as well as hepatitis B, there is a linkage with hepatitis B with liver cancer, and HIV, there's other cancers that are associated where 10 to 15% of cancers are associated with an infectious disease component. As well as infectious diseases are major concerns when we talk about it from an institutional standpoint, be it within hospital settings with nosocomial infections, within schools and prisons. Every fall, I always dread the fact that my kids are starting school. Most of us should be like, yay, your kids are starting school. But I dread the fact that now we are changing mixing groups, and within 3 to 4 weeks, I can almost guarantee that my kids will come down with one of the common colds that will be moving around within that school, with their classmates. And that brings us to talk a little bit about the epidemiologic triangle. And this model is used to explain the causation or etiology of infectious diseases. It's important for us when we talk about infectious diseases, what components can contribute as a major factor to pathogenesis of disease. You have to take into account the host, as in the human or the animal. We have to take into account the environment. Are the environmental conditions? Is the air temperature right? Is the water source that could be contaminated right? Are the necessary insects present? And then the agent. What is the infectious disease? Is it present? Is it all that transmittable? As well as, can it survive within the host? Can it survive within the environment? And what is preventing that? Now, it's important for us to think about it from that perspective of that triangle scenario where we have to take into account the agent, the host, and the environment. But you also need to remember that the causation of infectious diseases is much more complex than just, do we have a human host, do we have the right environment, and do we have an agent? Oftentimes there's this web scenario where we have multiple multiple factors that must be taken into account. For example, with avian influenza, which we've had some significant outbreaks in the past, in the last few years, when you take a look at all the components that are necessary to be present in order for humans to be infected, sometimes you ask yourself, how is it even possible for a influenza that usually infects birds? How is it even possible that we could even have it as a human type disease? And because when you start to look at the necessary contact that humans need to come into with certain types of birds, and those birds actually then need to come into contact with the type of birds or the flocks, chickens and other poultry. And will the virus then mutate? Is the environmental components necessary to present to allow for that? Do we have genetic reassortment that's taking place where the pig or the swine is an adequate mixing vessel? I mean, there's so much that one needs to take into consideration when you talk about causation of disease. So even though I present the triangle, and it is critically important that you understand that triangle, remember that each of those corners of that triangle actually may have other components that need to be taken into consideration. We are going to spend a few minutes now talking about microbial agents of infectious disease. I present this as not this is the know-all and the entire list, and we're going to cover every infectious disease that is out there. But I will spend a few minutes talking about each of these so that we can then begin to talk about the epidemiological calculations that you will need to master specific to these microbial agents and the transmission that's associated with that. We're first going to talk about bacteria. Bacteria were once the leading killers of and diseases with humans, and they still remain a significant cause of disease, but we know that many bacterial infections now are controlled by antibiotics. And with the advent of antibiotics, one of the major players in changing dynamics of infectious diseases with humans, it's significant. But bacteria still remains a significant component of human illness. And even more concerning is the emergence of antibiotic-resistant strains. And as you know, you have an opportunity to, and I'll come back to a few of those slides, but you have an opportunity to where you are to watch a PBS documentary talking about antibiotic resistance. And I ask that each of you do watch that documentary, even though you may not have completed that for the paper. Please watch that, because there will be an additional question or two that will be found on the exam. And so I do ask you to watch it, take notes, and that you'll be prepared for an exam question on antibiotic resistance.